Two things to review today regarding Lisp. Number one, how to create functions. Number two, data structures. So, functions. The syntactical structure of a function, the same that we reviewed before for other things. Open parentheses, closing parentheses. Your function is going to be inside. Now, after the open parentheses, you need a function ID. There is a function to create a new function. That function, the ID is the fun, definition of a function. Definition of a function, that is the keyword. You open parentheses, the fun, close parentheses. The next thing are parameters, and those parameters are going to define your new function. First parameter, the name of the function, the name of the new function. Next, the parameters for the function. The parameters for the functions is as list. So for the parameters, you are going to open parentheses and close parentheses because you are creating a list. So all this is the parameter for the fun. The parameters do not have a type. So the only thing that you need to provide is the name for the parameter. So in this case, 1, 2, 3 parameters, and you can put as many as you need. You put only the name, do not need commas. This white space is the one that separates one parameter from the other. After that, the body of your function, whatever you want your function to do, and you close the definition, as we mentioned before, with the closing parentheses. This is what you need to do to create a new function. Now, any function is going to return something. And as usual, your last line is going to define what your function is going to return. But I am going to show you some examples about it. Examples. Easy one. I want to create a function that's going to return hello world. So, open parentheses, closing parentheses, could be one line, could be several lines. Remember, the enter is not relevant. Open parentheses, closing parentheses, definition of a function. The name for the function is do hello world. I put several words together just to play with this, but you can use only one word if you want. Even if the function do not receive parameters, you need to provide a list as the second parameter of the definition of the function. So if you are creating a function that do not receive parameters, well, you can put here an empty list. So open parentheses, closing parentheses, nothing inside, therefore the function do not have parameters. And then the instructions. The only instruction that I am adding here, hello world, a string, something that we mentioned before. If you put a variable, or if you put, like in this case, a value, what is going to happen is that that is the value that the function is going to return. This example, what I am doing is do hello world, no parameters, and the body is basically something like that. Now, Lisp do not have types, but if you want to do something like this, maybe what you want is, okay, because I am returning hello world, I know that the return type of the function should be something like string. So this could be the equivalent of the code that I am showing you here in Lisp. Now, in order to use your function, this is the function definition, and the function call is going to be something like this one. Notice, I am calling a function. The syntactical rule is open parentheses, ID of the function, parameters. In this case, we define that this one do not have parameters, so use close the parentheses. Do hello world inside of parentheses is the code for the function that I create with the fun. No parameters, you put nothing but the name of the function. And you're going to have as an output immediately the value that you return. Now, this one is the output when you call the function. This one, what Lisp is going to show you after you create a new function is going to be the name of the function that you create in uppercases. So whatever name you put to the function is the thing that is going to be printed here as a result. So basically the confirmation that Lisp gives you to tell you, hey, now I understand a new function. And the name for that new function is this one. And it's going to give you that name in uppercase. Definition of the function, calling the function. Second example, open parentheses, closing parentheses. Instruction, the fun. I am going to define a new function. Name for the new function, @4, one ID. Parameters, one parameter. And the name for the parameter, x, without data type. We do not use data types, right? And the body for the function. The body, an addition, I am adding 4 to whatever I receive as a parameter. This one in Java, well, name for the function, one parameter, and the body. This one is the last line of the function. So that is the line that is going to be returned. So a return x plus 4, and x is the variable that you receive as a parameter. So I receive a number and I return a number. So the type for this one could be integer. This could be something like the equivalent for this one. Now, this is the definition. When you want to call the function, open parentheses, closing parentheses, now we use the name of the function as the one that we want to execute. We do not need the fun. And in this case, one parameter. So I put as a parameter 7, and I am going to get as a result 7 plus 4, and that result is the one that is going to be printed. So without parameters, with one parameter. Without parameters, returning a string. With parameters, receive an integer, return an integer. The last one. Definition of a function, the name for the function, and how many parameters? 2 parameters. The first one, the second one. And the return of this function, the body of the function, is the next line. As I mentioned before, you don't care about the enters. They are not important. The only thing is, because this parenthesis is going to be closed here, everything inside is the definition of a new function. So for this function, I have one big line at the body, starting from the center. I am going to do a multiplication of the first parameter times the same parameter, and the same for the other one. And then I am going to add and the square root. So I am doing this calculation of the hypotenuse of a triangle. In this case, for this function, this is the definition. And when I call the function is open parentheses, closing parentheses, name, the name that I provide to the function, and the value that I want to use for the parameters. So in this case, I have a triangle. The measure of the size is 7 and 9, and I calculate the value for the hypotenuse, and that is the value. That is the result. So no parameters, one parameter, two parameters. Hopefully you notice the model. That is the way that you create functions with Lisp. So more examples. Definition of a function. Name for the function in red. How many parameters for this function first n chars? Good, 3. So notice that the only thing that you need to do is to check for the white spaces. Notice that even though I use string n, and you can think like, oh, data type string, name n, just thinking about the previous languages. In this case, string is the name for the first parameter, n is the name of the second parameter, and notice that reverse it with the minus is one word. So that is the third parameter. So string, one, n, the second, and the last one, reverse it. So my function with 3 parameters. Now, I want to use if conditions in the body of the function. There is an if condition. So this is a method that has inside an if condition. Moreover, the condition, if you remember the if, is this one. The condition is use one value. That value is going to be true or false. Well, t or nil. With that condition, this line is going to be executed if the condition is true. This line is going to be executed if the condition is false. And I close the if here. So I have inside of my function one if, and depending on the if true or false, something is going to happen. That something is the instruction subseq that we reviewed in the previous lecture. And if this subseq is executed, whatever is the result of that subseq is going to be the result of the if, but because the if is the last line, in fact, it's the only line, that is going to be also the result for the function that I am creating. So basically, I am returning the value that this subseq function returns, or this one, if you are running the else part of the if. So the same function, but in Java, C, C++, again, we will have something like the return type could be string, just because subseq is returning that. We will have this name first n char, you're using this upper lowercase approach. We will have parameters, and here we can think like maybe the first one, even though it's called a string, in Java, C or C++, you need a type. That type is going to be string also with the S uppercase, the class. We have n. N probably is a number, so we need an integer number. And we have this reverse it. We can use the underscore, or if we follow Java, I can just make the I uppercase. So you decide. But because I am using that one in an if, well, that one probably is a Boolean value. So this is kind of the parameters for my function. If I review the body, what I have in the body is this if condition. The if condition is using as a condition the reverse it variable, and that's it. I mean, I am not comparing that one with anything. I just know that that one is Boolean, so it's going to be true or false, and depending on the value, I am going to return something here, and I have an else part, and in the else part, I define to return something here. I close, and I close. Something like that will be this one in the other languages. Now, I can call my function, and I can pass the first parameter is hello world, the string. The second parameter is 5. And if I want to pass the Boolean parameter, in this case, I can use nil, false. Therefore, it's going to run this line, not the other one. And the result is hello. Or I can use true as a parameter, and with the same input and the same number 5, this could be the output. So you notice the subseq, the first one is using inside reverse. So you're going to return a subseq with the reverse of the string, and the other one is just returning a subseq from the original string. So the original one is hello, a subseq in the original one, starting in 5, hello, the first 5 characters. In the second one, I do the reverse. So this D become the first element, and so on. And I return the first 5 that become the last 5 because I apply the reverse. So true or false, nil or T. One thing that you're going to notice, what happened if by any chance I use as a third parameter something that is not nil, not T, like I call my function, everything is the same as before, but here, instead of using nil or T, I put whatever, a number. You notice the result. Whatever you use that is not nil, well, it's like if you are not giving me false, then the assumption is you want this to be true. C++, 0 is false. Whatever else you use, 1 or other number, is going to be true. If you use nil, you want false. If you use T, you want true. And if you use any other thing but not nil, is going to behave like true. So I am sure that you remember this example. I am sure that you're familiar with the factorial function. And I am sure that you programmed this one maybe in the previous semester. This is Java source code. Calling the function, defining the function, right? So this source code is something that we can compile, run, and we know what is going to be kind of the expected result. What if I ask you to translate this from Java to Lisp? I am asking you for two things: definition of a function and call the function. And I put this column here with the same thing that you have before. It's basically this information is this information used as a reference. What if I told you that this is the answer? So can we understand how we create this one from this one? Let's see. The first thing that I have is all the modifiers from Java. We can ignore those. The second thing that I have is this function is going to return double. I don't care about the type. The only thing that I need to remember is that I want to return a number. But the type itself, I can ignore it. The name is important. So I can start with Lisp, open parentheses, definition of a function, and I want to use a name for the function, factorial. Then I have one parameter, and I know that that one parameter is going to be a number. I don't care about the type. The only thing that I care is the name of the parameter is going to be n. I need the parentheses because all the parameters should be together in one list, and that list should be the second argument, the second parameter for the def function. So open parentheses, closing parentheses, and I want this one, the parameter n inside. Next, something that I read here is that I am doing a local variable, and that local variable sum is equal to 1. So we need a local variable. We want a local variable. If you remember, to create a local variable in Lisp, we use let. So the first line for my definition of function, the first line in the body of the function factorial is going to be open parentheses let, because I want a local variable. Then the local variable that I want is sum, and in particular I want that sum to have the initial value 1. If you review let, the instruction let receive one parameter, the first one, that is a list, open and closing parentheses, and that list have inside list of elements, which each element inside of the list is two things: the name that I want for the variable and the initial value for the variable. In this case, the list have one element inside another list that is the name of the variable sum and the initial value 1. Very, very important. 2 times open and closing parentheses. First, to enclose all the local variables that I want. Inside, for each local variable that I want, open and close parentheses, because I am enclosing the name and the initial value. In this case, because I have only one local variable, it's going to look like twice the open and twice the closing parentheses. Now, after I define my variables, this open parenthesis is not going to close until the end, because all the instructions that I want to use that local variable should be inside of the let function, right? So open the definition of the function, closing the definition of the function. Open let, closing let. The body for the function is just one big let function. And that let function have this local variable and then some lines, these lines, that are going to be using that local variable. But well, let's review. Next line is a for loop. And I want a for loop to go from 0 to n. If you apply what we reviewed before, here in Lisp, the replacement for that is our do times function. Moreover, for the do times, you have 2 or 3 parameters. In this case, we're using 2. We are not specifying a particular return thing. And the only thing that we define is the name of the variable that I want to use as a control variable for the loop. I use I here. I am going to use the same, just to do the equivalence. And the second parameter is how many times I want this loop to run. And just like before, I want the loop to run n times. So name of the variable for the control, how many times the loop is going to run. This one is equivalent to the for that I have here. Now, inside of the for, what I want to do is this sum equal sum times 1 plus I. If you remember, the replacement for the equal, the assignation, is this setf function. And that is going to be the first one, just because the precedence of the equal, remember, is the last thing to happen. So the last thing to happen. Then what I want to do is to do an assignation, setf, in sum, that is the name of the variable that I'm going to use, and this is the operation that I want to happen. If you notice, first thing to happen, 1 plus I. You can do parentheses plus I1 just to play with something different. I am using this 1 plus, remember, the function that incrementing 1, and I am using only one parameter I, but you can use the plus, and you can use the 1, and you can use I. That is exactly the same. You can use whatever you prefer. So that one is going to happen first, and then a multiplication of that thing times sum, just like is happening here, and then the set f. The last thing that I want to happen in the original version is this line return sum. Now, return sum in Lisp, we do not have a return keyword. The only thing that we need to do is to put sum as the last line, in this case, in the let instruction. Why? Because the let instruction returns whatever you put as the last line. Notice that we do not use the parentheses for sum because sum is not a function, it's a variable. But that you put the name of the variable alone, that one is going to be replaced for the value. And because this line is the last one, that is the value that let is going to return. Moreover, because let is the last instruction in the function, that is the value that also the function is going to return. So when I finish the definition, Lisp is going to print the name of the function in uppercase, just to let me know that now I understand a new function. Now I learned something. Then I can call the function, open and close parentheses, the name of my function with one parameter. You call this one, and here you have the result. Now, I asked you for the result using the Java version and the Lisp version. Can you call this one, the Java version, of the factorial method and ask for the factorial of 1000? And it's too big. What is going to happen if you define the equivalent in Lisp and you just run this factorial of 1000? You are going to get the result. My advice, try both. I am sure that you should have this one in your computer. I am sure that you did this one sometime. Try. Do this one. And I am asking the 1000, but you can try with other numbers. And you can notice what is the big difference between one and the other. And in the case of Java and Lisp, both are running with an interpreter. Now, I am sure that you remember this one. It's the recursive one. It's the one that have only an if-else condition, no loop, and, well, you calculate the factorial using a call to the same function factorial. This is the source code, again, with Java, C++. The equivalent in Lisp. This is the same that I showed you before, just as a reference. I put the important elements in one column, and this could be the equivalent with Lisp. Now, the return type is a double. We don't care. We only need to remember that we want to return a number. The name for the function. Now, open parentheses is going to close here. Inside, definition of a function, and the name that I want to use, factorial, the same that before. One parameter, no data types. Inside of the function, the body, this if else, and I want to return things inside of the if and inside of the else. Good. We have open parentheses, closing parentheses, and we want this if condition. The condition, the parameter lower or equal than 1. The parameter lower or equal, than 1. There you go. Lower or equal than 1. The only thing that looks different is that now the operator go first instead of being in the middle. If true, I want to return 1. Here, I do not have a return keyword. I do not need a return keyword. The only thing that I need is the value. It's a value. I do not have parentheses. Therefore, if this condition is true, the only thing that is going to happen is this is the value that the if is going to return. And because the if is the last line, the only line inside of the function, is also the value that the function is going to return. The function is going to return 1. Notice, no parentheses, no quotation marks, nothing. Use 1. And if you want to put this 1 here in the previous line, is completely fine. Remember, the only thing that you need is a white space as a delimiter. That's it. Then, the next thing that you want is what happens when the condition is false. What I want to do if the condition is false is to return n times a recursive call to factorial. Well, what I want to return is the multiplication of n, and the second parameter for the multiplication is this one. And as you notice, open parentheses is going to close, and this is the name of the function that I want to call, and it's exactly the same name that the function that I am defining. So you call the function, and the parameter for the function is only 1, and now, as you notice, minus n1, so n minus 1. This is this one, and that is what I want to return. Close the else, in this case, close the if structure, end of the method. End of the method. When I press the enter, Lisp is going to tell me factorial. Now I understand factorial. So I can use a call to the function factorial, and again, you can try with 1000, or you can try with the classical 5 or 7 or something small, and you can compare both versions. In particular, when you use recursion, you use more resources than the resources that you use when you create something with for loops. So this is the kind of questions that you could have later in your exam, from here to here, or the opposite. I chose this example with Java, but the same idea with any other program, C, C++. I showed you the factorial just because I want to show both the loop and the recursive calls. Practice. Good. Guys, see you in the next lecture. Thank you.